Lesson 5.8, B as in boy, college algebra, continuing with partial fractions. We're in example 2. Move that up a little bit. Alright, so let's look at the degree. Degree of this is 2. What is the degree of this? Well, if we were to multiply these together, that's a 2, and this has a 1, so we're going to get a 2x cubed in here when we do FOIL. When we multiply this times this twice, we end up with a 2x cubed. So the degree of this is a 3, the degree of this is a 2. So this is correct. We want the numerator to be less than the degree of the denominator, so that's a good thing. This right here causes us a little bit of grief. Now, not much. It's pretty much just remembering what to do here rather than having it be really hard. Alright, and so, boy, explaining this is always so hard. I'm just going to write down what we're going to do here and then I'll explain why. So this is going to be over 2x minus 1. Okay, fortunately this is already factored, so I'm good there. And then I'm going to put a b, and this is where it gets kind of weird. I'm going to put an x minus 2, and then I'm going to put a c, and I'm going to put an x minus 2 squared. Alright, so what's happening here is because this is squared, we get an x minus 2 to the first power and x minus 2 to the second power. If this was a cubed, x minus 2 to the first, x minus 2 to the second, and an x minus 2 to the third. We'd have an A, B, C, and D. Okay, now, I'm just going to kind of give you an idea of where this comes from. Alright, so, on the side problem, let's look at just a fraction, 13 over 24. This has nothing to do with this. I'm just using a couple numbers just to kind of give you an idea. This is 2 times 2 times 2 times 3, right? That gives you 24. It also is 13 over 2 cubed times 3. It's also 13 over 2 squared times 2 times 3. Okay? It gives you a bunch of different ways you can factor 24 down. Well, which one is the right one? Well, this here, see, we have it squared and then times this, so I went from 2 to 1. Okay, kind of what I did here. Instead of writing this as 2 cubed, like here, I'm writing it as 2 squared times 2 times 3. 2 squared times 2 times 3. Okay, I'm just showing you that we have to write down the possible ways you could add the, or multiply these, or add these, I'm sorry, to get this here. Alright, so kind of like this. It's a bunch of different ways you can factor 24, so we have to take those into account. So I know that doesn't really explain it to you, but at least it gives you a little bit of an idea of what's going on there. The key thing is just remembering to put this x minus 2 to the first power, x minus 2 to the second power there. Alright? Okay, so let's go ahead and find common denominators to this. Okay, what am I missing here? I'm missing an x minus 2 squared. So I'm going to write that there. Okay? In here, what am I missing? I'm also missing an x minus 2. I'm missing just an x minus 2, right? Because I already have one of them. Top and bottom by x minus 2. And I'm missing that there. Oops, I don't need a b there, do I? So see what I'm doing? I'm looking and seeing what I'm missing in the other fractions. So I've got an x minus 2, but here I've got an x minus 2 squared, so I'm missing 1. So I multiply top and bottom by one of those, and now I've got 2 there. And I'm missing that, so top and bottom by that. Now I look at c, and I have a c. I already have an x minus 2 squared, So all I'm missing is this here. Okay, so I've got all of that, and that equals this here. And I'm not going to write it all down. So now that I've got that, my denominator here and my denominator here are all the same. So all I'm going to do is compare my numerators. So 7x squared minus 29x plus 24 equals A B and C. Okay, that's all I care about. You know, obviously I care about this original problem. I don't know if I can move that or not. Let's see if I can. Yeah, I can take a lot of it. So we'll take this and just kind of move it over here for later so we can look at it. But let's get rid of everything else because we don't really need anything except that right there. And what in the world do we do that? All right, so let's see what we've got here. We're going to set 2x minus 1 equals 0 to get rid of the c right here. So 2x equals 1, x equals 1 half. Okay, so we're going to try x equals 1 half. So let's erase that. And we're going to put x equals 1 half in there for everything. Okay, so we go through all of this, and what do we have? Well, our c disappears because we have 2 times 1 half is 1, 1 minus 1 is 0, times c, so that disappears. So that goes away. We also have 2 times 1 half is 1 minus 1 is 0, times this, times b, so that disappears. So all we have left is this, which when you do all the work for this, you end up with 45 over 4 for that, equals, let's see, this is 4 over 2, so 1 half minus 4 halves is negative 3 halves, times negative 3 halves squared is going to be 9/4 a, and then invert and multiply, and you get that cancels. 45 over 9, a is 5. Okay, so we found our a. All right, now we go back to the original problem here, and we set it equal to x minus 2 equals 0. So let's go ahead to see if I can get rid of any of this without completely wiping things out. Oh, good, I can. All right, so let's put in 2 for our x's. Let's see what we get. 7 times 4 minus 29 times 2 plus 24 equals a times 2 minus 2, the quantity squared, plus b, 2 minus 2, 2 times 2 minus 1 plus c times 2 minus 1. Alright, so we do this and we get negative 6, and that equals, this disappears because this 2 minus 2 gives me 0, so 0 times all of this is 0. And that gives me 0. Or I'm sorry, it doesn't. It gives me 3c. This gives me 0. so my a's disappear. And I find out then that my c is negative 2. So far I found out that my a is 5 and my c is negative 2. So at this point, I found an a, and that's 5, and a c is negative 2, which means that I have one variable left to find there, that b. So what I'm going to do, and this may seem odd, but it will work, is I'm going to put any number I want in for x, except the ones that I put in there before. What did I put in there before? 1/2 and 2. So I can't put a 1/2 or 2. So let's find a real easy number. Let's put 1 in there. And let's replace the a and c with what I already found. So I put 1 in there just because it doesn't change anything. And we found a to be what? 5. We're looking for b. And c, what did we find c to be? Oh, that was negative 2, right? Okay, so let's solve this side over here. And we find out it's 2. This is going to be negative 1 squared. So that's 1, so that would be a 5. This right here, this b part, will be just negative 1b when you put all these together. And this here is going to be 2 minus 1 is 1 times negative 2, so it's going to be minus 2. So 2 equals 3 minus b. Subtract 3 from both sides, and we get negative 1 equals negative b, or b equals 1. Okay, so we found all 3 of them. So I'm going to pull our original back in here again, and our a is going to be a 5. This is going to be a 1, and this is going to be a 2. So instead of an a, b, and a c, we have 5, 1, and 2. Okay, so again, real quick, since I only have another minute or so. We find a, b, and c by plugging in a number that makes this 0, plugging in a number that makes this 0, gets rid of your a or your c, depending on what you're looking for. So we found our a and our c. Then we plug any number we want in here for x, as long as it's not what we plugged in earlier. We put what we found to be a in here, so we put the 5 in here, see right there. And then the 2 we put over here, and then we just solved it because everything went away. I mean, our a and our c, we substituted numbers in there because we knew what those numbers were. We're just looking for this number now. So we put what we knew to be true in there, and we solve it, and we got a 1. We put the 1 there, and there is our decomposition. 5 over 2x minus 1, 1 over x minus 2, and 2 over x minus 2 squared. So now when we add these, we will get that original fraction back again. Alright, so next video is example 3.